Hello students, a very warm welcome to JEE English by Unacademy, India's leading and largest JEE test preparation platform. And today we are on your PYQ session of Gravitation, and as you know we have already completed your JEE Advanced Gravitation session and we are on to your 2019 PYQs, and we will be potentially wrapping up your 2019 PYQs in next few like probably in another day or so or in another session or so. And students, that being said, we are going through the problems that have not been asked repeated again and again. That means there were few problems that was asked multiple times. So we are skipping those problems. Make sure you're completing all of those sessions because I've noticed that there were like 2 or 3 problems that was asked in 2019 and 2018. They were basically the same questions. So yeah, let's get into this lecture. Let's not wait anymore. That being said, I'm Muralidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top ranking American university. I'm also an IITian who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams. And I have filed 25 patent applications on state-of-the-art technology in India, US and Canada. And students, if you are looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be an Unacademy subscription any day. And what do we provide? We provide daily live interactive classes with the best educators across the nation. In fact, we are authors of your popular JEE test preparation books like DC Pandey and DC Gupta on our platform, with whom you can attend these classes on a very interactive platform with polls and leaderboards, where your learning becomes very interesting. And not only that, we provide lots and lots of test series set by the best educators, and post which you will be also getting like analysis using which you can improve upon your overall performance. And you'll also get access to lots of live doubt clearing session, which is one of the most important component of your JEE preparation. And not only that, students, think about it, all your courses, all your programs, each and every program and courses are going to have live doubt clearing session. In fact, every 4th session is going to be a live doubt clearing session. That way you don't have to worry about having any doubts in your mind. We have dedicated doubt clearing session to take care of your that particular issues. And not only that, you will get every 4th session as doubt clearing session with your courses. So yes, every course is going to be fully structured. You don't have to worry about the planning. They come with live doubt clearing sessions and scheduled quizzes and mega quizzes. So yes, not only that, students, one more important thing about Unacademy subscription. So we do not restrict you by any batches. You can get unlimited access throughout the period. You can access multiple programs while you are having your Unacademy subscription. And how do you avail an Unacademy subscription? Do log in onto your web-based version or on your app, and then click on the left-hand top corner extension bar, select plus, select IIT JEE as your goal, and hit on this get subscription button. And post that, you'll be having an you'll be redirected to the program page. And probably you already know which program you should be going for. And among those, if you are a 2021 aspirant and if you do not have any plan for drop, you may want to just go for a 6-month program, which is going to cost you near about 25,250. And let's say you are a 2022 aspirant and you may be even a 2021 aspirant, but you have a plan for drop, then definitely do go for a 12-month program. Or you could be also 11th class student who's about to get into 12th class and has completed 30% of the syllabus, and you will be getting into a 12-month program which is going to cost you less than 34,650. And you could be a 2023 aspirant. Why this is the right time to start? This is an amazing time to start because you have 2 years. 2 years is the amount of time that you need for your preparation. And not only that, we have started some of the classes, be it even for 2022 and 2021 aspirant, by some of the best coaching institutes for your JEE preparation. And yes, 2023 aspirants will be going for a 2-year program, which is going to cost you 50,400 for 2 years. That is like near about 25,000 per year, less than 70 rupees a day. So this is about a plus subscription. We have something beyond plus subscription known as iconic subscription. So what is this iconic subscription? On iconic subscription, you not only get access to the features of plus, but along with that, you will be also getting access to one-on-one mentoring session personal coaching from IIT and NIT alumni who are educators on our platform. So think about it, IIT and NIT alumni who have previously gone through this journey will be efficiently be able to guide you throughout this journey, and they know the ups and downs. They will be giving out those motivation sessions that is needed for your overall improvement in your preparation, and they'll be guiding you with the strategies that you need for preparation and for performing in your exam. So it's going to be like a complete package as well, like just like your plus, but along with that you will be getting additional things that you need for like enhanced preparation, and with all the kind of personal guidance based on your preparation as well. You can get advisors from your educators. And yes, if you can afford it, this is going to be one of the best things for your JEE preparation. And how much is this going to cost you? A 6-month program is going to cost you less than 35,000. 12-month program is going to cost you 58,500, and a 2-year program is going to cost you 90,000 for 2 years. That is like 45,000 per year. So yes, make sure you apply Murali Live code, be it you go for 6 months, 12 months or 24-month plus or iconic subscription, so that you get maximum discount on your subscription purchase. Right? So yes, not only that, you can apply Murali Live code to unlock many features on your Unacademy subscription platform or learning app. For an example, the upcoming Unacademy Combat, you can unlock it with Murali Live code, and you will be able to avail it for free. And any feature that you're going for, you will be able to notice such features, such places where it will be requesting for a code to apply Murali Live code. And not only that, we have recently introduced something known as combo subscription. What is this combo subscription? A combo subscription is nothing but like your IIT JEE preparation and CBSE board preparation on an Unacademy subscription platform at an economical price with the best educators across the nation. So yes, it's an overall package both for your board coaching and your IIT JEE coaching at an economical price. So make sure you apply Murali Live code even on combo subscription, because discounts are also available on combo subscription, and your combo subscription prices can go as low as less than 90 rupees a day for 1 year subscription and less than 120 rupees a day for 2 years subscription. Alright, now let's get into the class. It's going to be super interesting class, students. Today we are on to the 2019 problems. So yes, what do we have over here? Okay, this is rather a very simple problem. It's actually basically a lot of numericals involved in it, nothing more than that. So there are 2 stars and they have masses 3 into 10 to the power 31 kg, and distance between them is 2 into 10 to the power 11 meters. Okay, everything is in SI unit. Make sure while you are doing your calculation, everything is in SI units, and also notice the units of the options. Very important. Okay, it could be kilometers. That is quite possible. And they're rotating about a plane in a common center, and a meteoroid is passing through them, and it is moving to some point O, that is that center of that both plane of rotation or that circle of rotation, whatever you would like to call. And in order for it to escape from the gravitational field of this double star configuration, what should be the minimum speed of meteoroid? A very practical problem, you can think about it this way. But now just imagine, why O is that point that we should be considering, because O is going to be like the minimum distance between that meteoroid and those sets of planets. That means that is the place where it is going to experience maximum gravitational field. So might be that, or might be like it is just passing through that. Once you need to do the calculation and confirm it, but let's now calculate it. Okay, so you have actually 2 stars. Okay, let's call this as star 1, and you have something like this star 2. Okay, now what is happening? A meteoroid is passing through center O. Okay, now you can think about it like this. It's a very easy problem. It's a very interesting problem as well. So we have some body with some mass that is passing through this place, and does this mass matter? Not so much, or not at all actually. Okay, So yes, now we do have this two stars. So basically now, first of all, first thing that we need to understand in this case is these stars. Okay, we'll be doing a question today on a very similar concept. These stars are rotating due to the mutual gravitation. Nothing to do with this in this problem, if you understood that point. So they are rotating due to gravitational force between them, due to which there is a, like, you know, like a centrifugal force, and they are rotating about it. Like a centripetal force, and they are rotating about it. Okay. Now, a meteoroid is passing through O. Now we need to find out, in order to escape this field, what is that minimum thing that is required. So what are we going to do? You know, we are going to do something like this. Say, this distance is R. So what do you think should be done in this case? Like, we need to find out that point, you know. Let's assume the star little bit, let's change the star position. Supposed to take it like a straight line, and let's, oh my goodness, okay. So star 1 was here, star 2 was here, and we had this meteoroid over here. We have R. That's it. That's what we need to do. So what we need to understand here is this meteoroid to pass along this line. I think rather than that picture, this picture is more clear. So to pass along this line, this meteoroid is going to have maximum you know, like kind of like, you know, bound energy at this point, and you need to find out what is that kinetic energy that this meteoroid would have or should have, so that it would escape the field of both star 1 and star 2. Okay, so first of all, let's understand something. What is the distance between meteoroid? Radius of that, you know, orbit. Okay. And what is going to be the radius of the orbit? The distance between the stars is 2 into 10 to the power 11. Okay. So this total distance is how much? 2 into 10 to the power 11 some meters. Okay, that's convenient. It shouldn't have been in kilometers. Okay, that's pretty convenient, and radius should be half of it. So it's going to be 2 into 10 to the power 11 divided by 2, so 10 to the power 11 meters. Okay. Now mass is going to be how much of each star? It's going to be 3 into 10 to the power 31 kg. That is given to us. Okay. And what else do we need to know? Nothing more. And let's do a thing. Let's assume that, you know, these meteoroids, let's keep it as ms. And this meteoroid has some mass capital M. Okay, as shown here. Now let's do a thing. First of all, let's calculate what is the like, you know, potential energy at this point. Whether the energy at this point, if it is zero. So what I mean to say is, like this body in motion like this, or in either direction, if at this specific point, if this total energy is zero, that means it can smoothly escape, right? If this total energy is zero, then it can escape. That's it. That's all you need to know. That's all you need to know. That's all. Okay. First of all, let's calculate its potential energy, and then we'll come to know what should have been its kinetic energy. Okay, and potential energy is going to be due to both the stars U1 and U2, like if you call that to be S1 and S2, and both are going to have the same magnitude as such. Okay, so you could have also directly multiplied it to, what is it going to be, minus G mass of the meteoroid into mass of the star 1. I'm not writing it down separately because both are same, divided by R. And if both are equal, you're basically writing down the same term again, and we are multiplying it with 2. Okay, so we know the potential energy. If we know the potential energy, we should be adding some kinetic energy such that this becomes 0. That's it. That's all we need to know. That's the end of the story. Okay, let's do this thing. Total energy is equal to potential energy total plus kinetic energy, just kinetic energy of whom your like meteoroid, is equal to 0. Hi Lokesh, good to know. So which year you are in, Lokesh? Yep. So potential energy, we just calculated that thing. We need to substitute the value here. We are not doing it. We'll do it at the end. So from both of this, can we say something like this? Okay, let's take a different. This specific quantity is what we are going to focus on and say that it's going to be equal to 0. Good. Do focus on this session and the next session and try and complete current and electricity. I know you guys must be knowing that, but try and complete current and electricity, magnetism, and also your electrostatics, optics, these topics. If you're in 12th, I believe your exam is in next few days. You should be focusing on that. And yeah, gravitation can be one that easy topic that you can do. Absolutely focus on PYQs, and that's why we have your PYQ session, students. Really, that's simple. Okay, this is going to be what? This is going to be half of absolute m. In this case, m is not of planet but of your meteoroid, is equal to 0. Okay, now what do we need to do? Okay, this r is radius r. I hope this is just that small r. We'll be changing it in the next line. So first of all, as I told you, mass independent. So forget that thing. Then we'll be having this 4 on the numerator. So we'll be getting something like v square is equal to 4 into g into ms divided by r. Okay, that's it. If you know the kind of escape velocity, you can multiply that thing with that does not work that way, right? Yeah, at least this thing will come kind of to your mind later on. This will become an obvious thing for you. Okay, now we have this thing. Okay, now let's proceed and calculate do that arithmetic calculations and get the value. That's all we need to do. Post this, just substitute the value of g, etc., and get the value. That's it, students. That's it. So we have 4 into how much? G, which is how much? 6.67 into 10 to the power minus 11, right? And what do we have? Mass of your star is how much? 3 into 10 to the power 11. Sorry, 3 into 10 to the power 31 kgs. Divided by r square. R square was how much? 10 to the power 11 whole square. Okay, that's going to be like it's 10 to the power 22. 10 to the power 22 cancelled. It gives you how much? 10 to the power 9. Is that it? Yes. And then what do we have? We have something like this and this gets cancelled out. And what do we have? 10 to the power minus 2. And what do we have? That's it. We can approximately take that 6.666666 or 6.67 into 3 is approximately 20. Okay, this can be written as further v square is equal to some 20 into 4 into 10 to the power minus 2, right? So this is the value that we have. Of course we should be focusing on taking its root. Either we can do a thing. You know what? Let's just do the calculation and finally just see what happens. Well, let's take the root. If I'm going to take the root, what happens? So 2 we can get it out, right? 4 is nothing but 2 square, and 10 to the power minus 2 is going to be 10 to the power minus 1. Okay. And 20, again there would be a 4 into 5. So think about it as 4 into 5. Then we would be having another 2 outside, and inside the root we would be having a 5. So what do we have? 0.4 into root 5. Okay, what we have out our, if any of the that we are probably making some mistake here. What kind of mistake is going wrong? Meter square, okay, that is fine. 10 to the power 31, yes, that is all. Everything is fine. Okay. Another mistake, it's not square at all. Everything goes wrong. Just pardon me. Let's correct this point. Hi Varun. Hi Varun. Hi. No Varun, I did my junior college from Hyderabad, and I also did my earlier education from. So let's just rework this quickly. I think this is where the mistake happened, because that kind of velocity should not be possible either. Okay, quickly correct this thing. So this should be like 10 to the power 20. This should be like 10 to the power minus plus 9, right? And what do we have? We have 20, right? 6.67 into 3 into 4 into how much? Like 10 to the power 9. Okay, now this is actually easy. Okay, that's what I was thinking. We are getting a super complicated value. So what is this? This is like 10 to the power. We can take this to be like 4 into 10 to the power 10, right? Under root into that of like under root 2. Okay, let's do this. This is nothing but 2 into 10 to the power 5 into root 2. So basically we'll be getting a value like, totally my mistake students, please do correct it, 2 root 2 into 10 to the power 5 meters per second. Yes Devra, yes, do focus on this. So how much this comes out to be? 2 into root 2, 2 into 1.4, that's going to be 2.8 into 10 to the power 5 meters per second. End of the story. And you know, root 2 value, it's 1.4. Okay, I think that was like carryover mistake. It shouldn't have been square. It's basically to the power. That's it. All right, we would have the answer somewhere here. It's 4, and there's a confusing option over here. Okay, so yeah, be careful about the units. Also be careful when you are carrying out the calculation. Okay, now let's get on to the next thing. So what do we have over here? A satellite is revolving in a circular orbit at a height h from the Earth's surface. Minimum increase, so h is less than r. Notice this point. This is very important for us. Okay, now what is happening? This is some kind of problem that we have been very often doing, right? Like we used to do this very often, like h is less than r. Then what happens? It's a very simple problem if you focus on this. The minimum increase in its orbital velocity required so that the satellite could escape from the gravitational field is closed. One thing you should be knowing is it should be root 2 from that height. So first of all, let's do a thing. You have, you know, satellite which is revolving around this. So this height given to us, this distance that has been given to us, is very small, right? How much? Very small. So we can say h is less than r. Okay. No, not necessary, Krishna. No, Kishan, not necessary at all. Okay, you don't need to sometimes do those things. Binomial approximation is one thing that you can do that would have created confusion in your exam. Definitely, I agree that point. Yeah, don't do that in this case. In this case, you won't get the solution if you do that. You are absolutely correct. You can do binomial approximation as well. But what I am going to say is h plus r is going to be approximately equal to r. Okay, you are correct. It should have been like binomial approximation, but you will not get the answer. But that thing you'll understand once you started to complicate things, right? And from this given options, you would not be able to get the answer. Okay, that is where you'll get stuck up. Really good question, like really good thought process. Like that you can go by binomial approximation and get the answer. Then why not I do that? Why should I even go by the method like what I'm saying? Now here comes the thing. Binomial approximation, if you had applied here, somewhere h should have appeared, right? Nowhere h is appearing, okay, in the given option. Okay, that means no h. Then what is the next thing that you're probably supposed to take r plus h approximately equal to that of r. Really good thought process. Yes. Okay, so now that being said, you have a satellite, right? And now this satellite is moving with certain velocity. We know what is the velocity. What is the value of that velocity? Under root gm by r. Let's do a thing. It's all given in terms of g, a gravitational acceleration on the surface of Earth. So we'll be converting it in terms of g. So we can say this. I hope you remember this point. Gm by r square to that of r under root, which means this term is nothing but g. So velocity should be how much under root g into r. Okay, now this is initial velocity. Okay, and we know one more thing. Potential energy is something, what it is going to be, minus gmm by r. Okay, let's start from there. Now let's move in a different direction for solving this problem, not the way that we used to do until now. So what is the potential energy? Potential energy is going to be minus g m of the satellite. Let's give it small m, mass of the satellite, and mass of divided by r. Okay, so now let me ask you this question. If this is potential energy, what should be kinetic energy? Kinetic energy should be just be half of it with a positive sign. Total energy is going to be half of it with a negative sign. Kinetic energy should be half of it with positive sign, right? So this is going to be how much? Like gmm divided by 2r. Okay, now the question is how much more velocity you will be giving, so that this is current. Okay, this is current kinetic energy. Now how much more velocity you will be giving, how much more kinetic energy you will be giving such that it would escape this, like this particular orbit. Okay, total energy is going to be negative half of potential energy. Okay, so in this case, let's say your satellite is somewhere over here and it's orbiting. Okay, what do we know? We know very interesting fact that total energy is going to be how much? Approximately this is nothing but just r minus gm m upon 2r. So we should be giving an additional kinetic energy so that it escapes this gravitational field. How much additional kinetic energy? Of this much. Okay, that's it, right? Okay. So now what should be the additional kinetic energy? Additional kinetic energy should have been delta Ke is going to be positive of this. This is because total energy plus the additional orbital or kinetic energy that you are going to give is going to make it 0. But we have done it several times. By now you should have already known the answer. So this is going to be plus of gmm by 2r, right? Now comes the question, what is the total kinetic energy? Now in this case, all kinetic energy plus that additional kinetic energy will give you total kinetic energy. So you are going to add up this same value, right? If you remember, it's all same value, 1, which is gmm by 2r, and which is the additional kinetic energy is also gmm by 2r. If we add 1 and 2, we'll be getting total kinetic energy. Why are we doing this? We are doing this so that we derive a final answer. But you can do it very quickly if you have already understood this point. Kinetic energy plus of additional kinetic energy is going to give you how much? Total kinetic energy, of course. And this total kinetic energy, right? Total kinetic energy, let me quickly. Okay. So total kinetic energy, question, really good question, equal to how much? Is equal to gmm by r. Okay, now we know this thing. So what should be velocity? Equate this to half of mv square. That's it, right? So we will be saying our final velocity. Okay, let's give this a small subscript vf. So we know half of mv final square is how much? Centripetal force could not exist, right? Once it is escaping Krishna, where is the centripetal force? Towards the center of the earth in general cases. And now this would not exist anymore, right? Because now due to this new kinetic energy or this total kinetic energy, what is happening? Your body is escaping the gravitational field, right? As usual, would go. So final velocity is how much? 2 gm by r under root, which is how much? 2 into gmr square into r. And to quickly remind you something, this is how much g. So what should be a v final? V final should be not, this is not g, this is totally wrong, right? This is not g, this is, there's a 2 in this, just be my mistake. Let me correct this quickly. Gm square into 2. Okay, so v final is going to be how much? Root 2 gr. Okay, that's it. Now we know this. What is the next thing we need to do? We need to actually not find out the final energy, but we need to find out minimum increase. So some increase should have been there. There should have been some increase in the velocity. What is the increase in the momentum or velocity, whatever we asked in the question, what it should have been? Okay, so it's going to be v final minus v initial, which is like root 2 gr. Okay, let's do a thing. Let's take out this gr out as common. And what do we have? Root 2 inside. And in the other term, what it was? Just gr. Okay, this is what the initial, right? End of the story. Simple question, actually, damn simple question. Let's move on to the next problem then. It's a very simple problem. See, total energy, we just did it. Okay, ratio of kinetic energy is being asked. Okay, we just did something where we said, I'll quickly take it through that point as well. Now, what is being asked? The ratio of kinetic energy. It's simply 1 if you have understood, because all we are concerned about is mass is to radius ratio, given that both are orbiting around the same planet. So here goes the question, something like this. There are two satellites A and B, and they have mass m and 2m. Okay, they have a mass m and 2m, and they are orbiting in a circular orbit of radius r, and B is in a circular orbit of radius 2r. Then what is the ratio of the kinetic energy? Okay, let's get into this question quickly. So there is like there's like a satellite, this satellite, and there is another satellite. And what about the satellite? The satellite is at a distance how much? R from the center. Okay, it's a simple question. You can simply understand this concept quickly. We are not even going to do this. What we are going to do, we are going to make use of few things that we know. What are those few things? That if we call potential energy to be x, what should have been our kinetic energy? Minus x by 2. That thing that we did earlier. Okay, so if we call potential energy at this point to be x, and they are bound, in that case it is x, then your kinetic energy should be how much? Minus of x by 2. Why minus? Because kinetic energy is not negative, actually x is negative. Okay, you'll understand that point very quickly. Okay, and we should be having a, and what is that major difference between them? This has a mass 2m, and the other guy over here, okay, mass 2m, also is satellite, and the other thing over here as a mass m. Easy, simple. Now let's get into the next thing. The next thing is we are going to make use of this equation to quickly get the answer. So this is A, right? What is the kinetic energy? TA is not total energy, kinetic energy, but it does not matter how much it should be. Minus of x by 2 minus of potential energy of A divided by 2. And how much is the potential energy of A? It's going to be minus of, if this planet has some ME, this is Earth, I guess, okay, minus GME into M by R into 1 by 2. Okay, first one is clear, right? First one we have the answer. Now let's move on to the next one. Okay, now in the next one, what do we get? We get total energy, kinetic energy of B is like minus potential energy of B divided by 2, right? We did a mistake. What is that mistake? We missed out that negative and positive. Okay, similar, because kinetic energy, one from the logic, it's not going to be negative, and in this case as well, it's going to be G into M into 2m, which is like given mass of satellite B, right, divided by 2r. That's it. So negative negative positive divided by 2 again, but if you have noticed it, okay, you notice this thing, this is going to be cancelled out. So total energy A is equal to total energy B, sorry, kinetic energy A is equal to kinetic energy B, TA by TB is going to be how much? 1:1. Okay. End of the story. Okay. Finally concluding, TA is equal to TB. That means TA by TB should be how much? B1. Right. Damn simple. Okay, now let's get into the next problem. Okay, simple. Yeah, this was that interesting problem that I was initially stating. You can have a question where, you know, all the four, like in this case it's four particles, multiple particles are rotating due to the mutual gravitational. Definitely do start trying out this problem. It's a very simple problem. Okay. There are four identical particles of mass m and they are located at the corners of a square of side A. What should be the speed such that they will be able to revolve under influence? Now comes nicest problem. Okay, do notice the options. One is like let's first of all have a look at it. Okay, just this number. Otherwise, okay, it's dimensionally consistent. Now the next thing is working around this problem. What kind of problem is this? Of course, gravitational field aiding the rotation due to its centripetal force, which is balanced by a centrifugal force. Okay, now that means they are all same kind of particles. They have mass m. Okay, m, and m. Okay, nice. Now it's a square, as you can see. It's a square as given in the question as well, a square of side A. Actually, it's given in very nice format. If this is twisted a bit, you know, it's given like, you know, like, okay, still I believe you would be able to do it. If it's given even in the straight manner, right, the diagram was given in the straight manner, still you should be able to do it. Okay, once you did this problem, you will understand how to do it. Okay, now they are all lying on the sides of the square. All of them would be having, you know, like same force on them. And now let's understand this point. Okay, first between these two, what is the direction going to be? Like this. Let's call this as force F1. And due to these two, it's going to be force F2. Line joining them. Line join them. Give them a vector sign. Now, magnitude wise, okay, let's get into the kind of, you know, the numbers later on, exact numbers later on. Just let's focus on this problem. So, force F1 is equal to force F2 magnitude. How much is that? That is going to be distance between them, right? That is going to be G into m square. Basically, both these particles have m and m. All of them have m square, m into m square divided by a square. Okay. This is magnitude. Right? This is not the force, total force equation. First of all, let's do a thing. Let's understand this point. Now, force 2 and force 1 should be added, or force 1 or force 2 should be added. If you add them, what would you get? They are at a 90 degrees angle. So it should be root 2 times, okay, if this is like, let's say, some direction, you know, like like r direction, just directly between these two masses. Going to be in the r direction. Okay, r cap. Okay, let's for direction, let's indicate it with a cap, which is going to be rather easier. It's going to be root 2 times of that of magnitude of f1 or f2, whatever is given over there, into that of how much, like r cap, right? Because 90 degrees, same magnitude, you'll be getting what? You'll be getting under root 2 times that magnitude. Okay, under root of f1 square plus f2 square, basically f1 and f2 are equal, so under root 2 into f1. Okay, now this is first thing that we have. Now we need to do one more thing, one more interesting thing. What is that one more interesting thing? One more interesting thing is adding up this between interaction between these two forces, these two like masses. Okay, that's the next thing that we should be doing. Now, so for this, let's call this as something like f3 between them. First of all, it's going to be along the line joining, it's going to be along r cap direction. That's not a problem, because this is also going to be like this r cap direction, right? R cap multiplied with what? Multiplied with g into m and m, mass m, small m, sorry, capital M, capital M. What do we get? M square by what? Now comes the thing. What is the distance between them? Root 2a, diagonal. It appears it's a square. This is a, this is a, this is 90 degrees. This is how much? Root 2a. So root 2a whole square. Okay, good. Root 2a whole square. Now this would come out to be g into m square divided by 2a square into that of r cap. Okay. Now let's move on to the next thing. That is, first of all, write down this value, just give a feel of it. Finally, you don't want to write it down patiently. If it's in your exam, patiently means within the 2 minutes, and try to get the answer correctly. That is more important. Okay, now what is the total force, students? It's really simple. If I'm going to talk about net force, I'm going to add this quantity and this quantity, and that means net gravitational force on one of the masses is going to be how much? F1 plus F2 plus F3. That is going to be how much? Some gm square. It's going to be along the r cap direction. Okay, going to be along the r cap direction. Some gm square by a square appears to be common. Just take out that. We have gm square by a square is that like a common thing, and we have root 2 plus of 1 by. Okay. Now, first of all, we have got the force. We haven't yet got to the answer. What are we supposed to find out? We are supposed to find out the speed. Okay, the speed. Let's get into that. First of all, let's write down the force equation again. Force acting on this particle all along this direction, F net, this value is how much? Okay, F net is going to be how much? R cap into gm square by a square, that's what we have, 2 plus 1 by root 2 plus 1 by 2. Okay. Now comes the next thing. Next, a very important thing. Okay. Move on to the next. Now we need to deduce your centrifugal force, right? Let me quickly get to this one. Okay. This is the distance of this rotation. Okay, this is rotating about a circle of how much radius? This much radius. Draw this thing. This is the radius. This is the radius. What is the value of radius, students? It's very simple. I guess most of you must be doing this very quickly. What we have is like this thing that we need to find out, which is going to be should be root 2, a by root 2. Is that what it should be? Yes, because it's basically half of diagonal. That's it. Okay, so this is going to be how much? A by root 2, basically root 2 into a by 2. That's it. Okay, now we know this thing. This is the radius for which this rotation or this revolution is happening. That means centrifugal force for each mass is going to be a by root 2, right? This is, you can think about it either ways. It's a by root 2 or some two sides adding up to form a a, that would be like a by root 2 whole square plus a by root 2 whole square. That would also give you a, whichever you would like to go with, but half of diagonal could have been easier. Okay, so this is going to be how much? M into v square by r. Okay, and in this case, how much is this? M into v square divided by into v square by mv square, confused a bit, into root 2, a by root 2. Okay, we are now supposed to equate both of the terms. That's it. The end of the story. F net is equal to F centrifugal, because it is in this direction, that is also supposed to be in that direction. Okay, always towards that center. Let's do that and see what do we get. We have m v square divided by a into that of root 2 is equal to, okay, r cap, forget that r cap, everything. This is going to be minus r cap. In terms of magnitude, they should be actually be equal if you're okay. And what this should have been, yeah, this should be like gm square divided by a square into that of root 2 plus of 1 by 2. Okay, now what are we going to do? Cancel out first of all things that are very inconvenient for our calculation. M gets cancelled out and then a gets cancelled out, and you're going to carry over this root 2 on the other side. Let's on one more step. You're just going to write down just the values. What do we have? Root 2 into v square is equal to 2 plus 1 by root 2. What? No, root 2 into 1 plus. Okay, now into that of what? Gm by a. Okay, now divided by root 2. Yes, divided by root 2. Okay. V square is equal to, what do we have? Root 2, it's going to be 1 plus of something like 1 by 2 root 2. Okay. So here is where the twist lies. This is that part which you need to focus on for getting the exact answer. So from here we know what is the value of your velocity of, like, this orbiting velocity of this mass, some v, which is equal to how much? Create some space for other calculation. So which is going to be how much? V is equal to root of 1 plus 2 root 2, okay, into that of root of gm by a. Of course, this is a calculation which has to be quickly approximated. There is no other go other than that. Okay, what I'm saying is, focus on the thing that we are going to discuss. Just focus on this value. 1 by, like, 2 root 2. 1 by 2 root 2. Can this be written like this? If I'm multiplying with root 2 on the numerator and root 2 on the denominator, what happens? It's basically root 2 divided by 4. How much that is supposed to be? Root 2 is 1.414 something, divided by 4 is going to be like 0.35 and odd. Yes. So, is that correct? About it, yeah. Yes. 0.7, 0.35. Like something 0.35, 0.35 something, that will be a repeating value. Now, next thing, what we need to do is understand this point, that this is what? Root of 1 plus of 0.35, which is going to be root of 1.35, which should be, like a binomial approximation as well. I don't think that would be a problem. 1 plus of 0.35, then we write it down to be like 1.16. Okay, so what we can do here is simply that being said, okay, if you remember, we used to say this. Okay, so in your exam you don't have a calculator. How do you do this? You just write it as 1 plus 0.35 whole to the power 1 by 2, which can be written through binomial expression approximation. You remember that point? We just said that 1 plus x to the power n is equal to 1 plus n into x, given that x is a very small value. Yeah, x is 0.35. We can approximately take this to be 0.35 divided by 2. So it should be something like 1.18 or 1 something like that, 1.17. Yes, approximately it will come out to 1.1. So you can do this calculation a little bit, you'll get the answer. Okay. So this should be approximately. We don't know the answer yet. Okay. We don't know the answer. Let me erase this. Focus on this. It should be approximately how much? Let me just round off this. Okay. Should be how much? 1.17 something 5 and odd. Maybe it is less than this, maybe it is more than this, but definitely not something like 1.21. Let's go back to the options. This is the part that we need to analyze. See, this is what? 1.21. 1.21, when do you get that? I don't know when would you get that, but definitely we are not getting 1.2 and odd. We are not getting 1.41 and odd. We are not getting 1.35 and odd. Have been Little bit of analysis is required in this case because the options are very close. Else we can actually do, I think, 1.21. When would we be getting inside your root? It should be at least 1.4 and odd, right? 1.4 is not what we have. We have something like 1.35. Not 1.35, but a little less than 1.35. And of course, this option is given to just confuse you, right? Don't do this, don't do this, just the wrong answer. Okay, easy, simple, damn simple. Yes, you do some approximations. It's really an easy question, but a very interesting question as such. Okay, now let's have a look at the rest of the questions in the upcoming session, because we have another class at 7:30. We have a few more questions next class, like many more questions. Probably there are only, like, 5 or 6 questions left in 2019, and we'll also have a look at other questions of your past 10 years. And with that, we'll be completing both JEE Mains and JEE Advanced questions of your PYQs. And that being said, students, tomorrow, that is like Friday, from 10 a.m. to 1 p.m. we have a special class where on your Unacademy learning app. So yes, this is going to be part 4. Do not miss it out. And we will soon be wrapping up this 10 years PYQs of your current university, one of the most important chapter from which you can typically expect at least 3 questions, like 3 questions in your JEE Mains paper. So very important topic. Do not miss it out. If you have missed out any past sessions, you can totally go and attend them. 3 of them are also available on your Unacademy learning app. Okay, and also, that being said, we have already completed on your Unacademy learning app electrical measuring instruments in one shot. So this is like just one 4-hour lecture in which we have discussed all the concepts of your electrical measuring instruments. This includes a galvanometer coil based problem, and also your potentiometer, voltmeter, how to convert galvanometer into voltmeter, what is an ideal voltmeter, and what is this voltmeter in realistic circuits, how do you calculate around them, and what is this ammeter, how do you convert galvanometer into ammeter, applications of potentiometer, like comparing EMFs, measuring internal resistance, and also your how to measure EMF. Yeah, why not voltmeter to measure EMF, why potentiometer, and also your meter bridge based concepts, end correction, etc. There is also an end correction concept in your meter bridge and some error analysis that needs to be done. We have done everything just in this one 4-hour session. Okay, everything in detail we have discussed in 4 hours, and you can typically expect at least one question in your JEE Mains. This has become a recent trend that you can at least expect one question from your electrical measuring instruments. So students, think about it. All you have to complete is 4 hours and you will be able to crack one question in your exam. Totally worth it. And we have also discussed any different kind of problems that we came across, but do definitely go through the PYQ session to get kind of the understanding of electrical measuring instrument questions that have been asked in the recent years, in 2019 and 2018. And that being said, do not forget to get onto our Telegram channel. First of all, download Telegram app from your Google Play Store and App Store, and there is a link in the description box below. Just click onto this link and get onto our Telegram channel, where you will be able to get before time updates on every class conducted by our JEE English team. Okay, so we keep conducting classes on both your Unacademy learning app and YouTube channel, and all of this are free of cost classes. And you can get onto a Telegram channel and get before time updates on everything. And not only that, students, you can also get some updates on the news related to your exam. And that being said, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription any day. And why do we say that? Because we have the best educators across the nation with whom you can attend daily live interactive classes on a very interactive platform with leaderboards and polls, so that your learning becomes interesting. Not only that, we keep conducting lots of national level test series set by the best educators, post which you will be also getting analysis using which you can improve upon your overall performance. And you will also get access to lots and lots of live doubt clearing session, and this is one of the important major components of your JEE preparation. using which you can clear your doubts in the mind, and you would not have doubts because they are set in a very structured manner. You will be having dedicated doubt clearing session that comes with each and every program after certain number of session. And not only that, every program, as you know, on an academy subscription is fully structured programs, and they are taken in a very systematic manner with all the kind of doubt clearing sessions, regular classes, and quizzes and mega quizzes. And Unacademy subscription provides you unlimited access throughout the period, and there are no such batch restrictions on Unacademy subscription platform. And how do you avail Unacademy subscription platform? You will be downloading your app, or you can do it from web-based version, login, and select IIT JEE as your goal, and then you can hit on that get subscription button. And that being said, students, let's say you have been redirected to the the program selection page now, which is the app program for you. So let's say you are a 2021 aspirant. You'll be going for a 6-month program because you have 6 months for your exam. So how to get to JEE Mains handwritten? Hi Aravind. I don't know is the answer to your question, right? And if you're a 2021 aspirant, you'll be going for a 6-month program, which is going to cost you near about 25,000. And let's say you are a 2022 aspirant, that is like you might be a 2021 aspirant planning to drop, or you might be even a 11th class student who is planning to prepare next 1 year, or who have completed 30% of the syllabus. You will be going for a 12-month subscription, which is going to cost you less than 35,000, 34,650. And if you're a 2023 aspirant, you'll be going for a 24-month program, and you'll be having 2 years to build your fundamentals, basics, kind of prepare totally for your exam. And a 2023 aspirant, your program fee on plus is going to be anywhere around 50,400. That's like 25,000 a year, about 25,000 a year, less than 70 rupees a day. And this is about our plus subscription. We have something beyond plus subscription known as iconic subscription, where you can get one-on-one mentoring, personal coaching from IIT and NIT alumni who are educators on an academy platform. So think about it, IIT and NIT alumni who have previously gone through this journey and successfully cracked the exam, they know the ups and downs in this journey. They will be guiding you with the motivation sessions. Not only that, they will be also giving out these strategies that is required for your preparation, as well as for your exam, etc. So it's like a personal advice that you can get from IIT and NIT alumni who are also educators. That way they have the subject knowledge and they have the experience of going through the journey. So that's going to be an amazing experience for you if you can afford it. If it's going to be one of the best things. And how much is this going to cost you? Like a 6-month program is going to cost you 34,200. 1-year program is going to cost you 58,500, and a 2-year program is going to cost you 90,000 for 2 years. That is going to be like 45,000 per year. And students, make sure you apply Murli Live code, be it you go for 6 months, 12 months, or 24-month plus or iconic subscription, so that you will be getting the maximum discount on your subscription purchase. And yes, students, we have recently introduced something known as combo subscription, and this combo subscription is like an economical complete package for both your JEE Mains, JEE Advanced, and also your CBSE board preparation at an economical price, where you can attend the classes from anywhere with the best educators across the nation. And yes, we do also have different combinations of this combo subscription, like your iconic and plus. Iconic of IIT JEE, plus of CBSE, full iconic, that is iconic of IIT JEE and iconic of CBSE, and plus of CBSE and IIT JEE, and plus of IIT JEE and iconic of CBSE. And this can start at a price of less than 90 rupees a day for 2-year subscription, and less than 120 rupees a day for 1-year subscription. And students, that being said, we are also present on iconic subscription, and you can take your JEE preparation to next level with our personal coaching. We can be one of the best team for your iconic subscription. We have a team of IITians and IITians and head of coaching institutes, and you can get in touch with us for our IIT JEE workshop, expert guidelines, study planner, test analysis, etc. And that being said, do not forget to like and share this video. Click on that bell notification and subscribe button to get timely notifications. Definitely do share it on your social media. Talk about this channel with your friends. Share it on your Facebook page, share it on your Telegram channel, WhatsApp groups, definitely someone like a 2021 aspirant will get access to this quality, high quality full length lectures, and yes, of course do share it, because sharing helps others learn as well. And yeah, keep smiling, work hard and smart to achieve your success. And students, today at 7:30 we have the PYQ session on magnetism, and we are also on the 2019 sessions of your magnetism. So do get onto it and enjoy this lecture, and do not forget to apply Murli Live code whenever and wherever necessary. It can be your Unacademy Combat, it can be your subscription purchase, it can be also your combo subscription. Even on your combo subscription you will get discounts, and it can also be like any feature that you are unlocking. Take care, stay safe, bye bye, see you in the next class.